Hello viewers, welcome to the session on Principal Component Analysis in Machine Learning. Please make sure to watch all the prerequisite videos for your clear understanding and to make best use of it. I hope by now we are very much clear about independent variables and dependent variables. So let's straight away jump into the definition of PCA. If our dataset is containing n independent variables, then PCA's job is to extract p new independent variables, which is a subset of m independent variables, such that it explains the most variance of the dataset regardless of the dependent variable. Confused? Don't worry, we are going to look into this statement in a diagrammatic way. Let us suppose we are having 4 independent variables which is determining our dependent variable y. Then PC's job is to extract a subset of these 4 independent variables such that it will give the same result. So let us suppose the PCS identify that only x2, x3 and x4 are the independent variables, which is giving us explaining the most variance of the dataset regardless of the dependent variable. And moreover, the fact that dependent variable is not considered makes PCA as an unsupervised model. As discussed in the previous slide, now in this slide let us look at how this transformation takes place. The main idea of the principal component analysis is to reduce the dimensionality of the dataset consisting of many variables which are correlated with each other, while retaining the variation present in the dataset up to the maximum extent. And this transformation is done by transforming the variables to a new set of variables which are known as principal components. In the earlier example of the earlier slide, x2, x3 and x4 were considered as a new set of variables which is nothing but our principal component PC. And these are the orthogonal ordered such that the retention of the variation present in the original variables decreases as we move down in the order. So in this way, the first principal component retains the maximum variation that was present in the original component, and it goes like this. Principal component 1 will contain the maximum variation with respect to PC2 and then PC3 and so on. Similarly, the principal component are the eigenvectors of the covariance matrix and hence they are orthogonal. Before moving ahead, let's quickly look at some of the important applications of principal component analysis. PCA is mainly used as the dimensionality reduction technique in various artificial intelligence applications such as computer vision and image compressions, etc. It can also be used for finding the hidden patterns if data has high dimensions. Some fields where PCA is commonly used are finance, data mining, and psychology. Now it's time for your favorite hands-on session on principal component analysis in Python. So before moving ahead, I am importing all the important libraries. See, it has been executed successfully. Now we are going to work on a blind dataset. Let me load it and show you what does this dataset say. Here we are having approximately 13, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and 13. Yes, exactly 13 independent variables and one dependent variable customer segment. This customer segment value is dependent on these 13 independent variables, and it is not obvious that all these 13 independent variables carry equal weightage to determine the dependent variable consumer segment. So hence we will use PCA algorithm to analyze how many independent variables is sufficient to determine the dependent variables. So let's look at it. Further, let me first segregate the independent and dependent variables. See, it has been executed successfully. X is containing all the 13 independent variables and my Y is containing the dependent variables. So let me split it into training and testing data set. See, it has been executed successfully. testing set is containing 20% of the overall data set. It has been executed successfully, and moreover when we look at the training data set, here you can see there is a huge variation. Here we are getting 680 values and here we are having 22 values. So we are going to apply feature scaling. For that we are going to use the standard scaler. All this has been explained in the prerequisite videos. So here just the implementation of the same. Now here the main chunk of code for implementing PCA stands here. First understand this. From sklearn package, I am using decomposition module and importing PCA class, which stands for principal component analysis. And under principal component analysis, I am creating an object, and initially I don't know how many components I should have. So I have given it as none. Let's look at it and analyze. We want a maximum retention of the same data set, so 50% will be quite enough. Further, I am making it the trained model and test model to be fit and transform, and after that the explain variance score. I would like to see the explain variance score of each and every independent variable. Let me execute this chunk of code for PCA. Let's analyze this. All these 13 variables. Wait a second. Yeah. See, these are the principal component ratios by each of the independent variables, and from here you can see that only the first two independent variables contain more than 50%. Is determining the dependent variable is more than 50%. 36 plus approximately 20 is 54%. So we are going to mention that the number of components here as 2. You can see the variation in the result. Let me execute this chunk of code again. See, it has been executed successfully. So in explain variance, we are having these two independent variables. Instead of maintaining 13 independent variables, we have determined that only 2 of the independent variables carry the most weightage to determine the dependent variable. Hence, we have given the number of components as 2. And the normal, let me check if what result we are getting by applying it into logistic regression. So it has been executed successfully. Again, I am going to predict the result using classifier.predict of the logistic model in logistic regression. So let me check into the confusion matrix. See, it is stored in C. You can have a look at it, how good prediction it is by applying PCA. So now let's look at the accuracy score of the same. See, it is giving 97% of accuracy. So for visualization, we have been using this same counter plot and uniquely enumerating through each and every set. So just we are going to execute this visualization code once again. The map listed color map. See, it has been executed successfully, and you can see the principal component 1 and principal component 2. As usual, I have included code snippet for your fast revision, so you can pause your video right here and can take screenshot of the same for your future reference. I hope this video proved fruitful to you and hope you have gained something extra than what you were knowing earlier. Thank you.